This reaction between hydrogen and chlorine seems pretty simple. Hydrogen plus chlorine makes hydrochloric acid. This video is going to tell you about the mechanism of that reaction. This is a radical reaction. Radical reactions start with something to create free radicals. This is called an initiation step. And in this case, the initiation is photodissociation, where UV light splits the chlorine molecule. Free radicals are very reactive species, and they have exactly one available valence electron for a covalent bond. We call this step photodissociation because it's dissociating the chlorine from one another with light, and we use the little dot after the symbol to indicate it is a radical. We use half-barbed arrows to indicate that each radical is taking half of the covalent bond. We use the notation H nu to indicate that it is a photon of light. After initiation comes the step propagation. Now, propagation will always leave you with free radicals. So in this case, the chlorine radical is attacking the hydrogen bond, and you get hydrochloric acid plus a hydrogen free radical. Another propagation step would be the hydrogen radical left over from that going and taking one of the chlorines from one of the chlorine molecules. Again, it gives you hydrochloric acid plus a chlorine radical. So propagation steps always make radicals. After propagation there comes termination, and termination is where free radicals come together to make non-radical species. It's called termination because it will remove radicals and therefore end the reaction. It's the end point of the reaction, if you like. So here we have hydrogen radicals coming together to make hydrogen again, or chlorine radicals coming together to make chlorine again, or indeed a hydrogen radical and a chlorine radical coming together to make hydrochloric acid. And there will be more of this, hence the overall reaction from hydrogen plus chlorine into hydrochloric acid. So what you need to really remember about radical reactions is that there are always three steps: initiation, propagation, and termination. Initiation involves dissociation, usually with photon energy or H nu. Propagation makes radicals, uses radicals, and makes new radicals at the end. And termination always leaves you with non-radical species. So termination removes radicals. What you should be able to do then is actually use that knowledge to predict radical reactions. So here's the radical reaction bromination of methane. Start with bromine and methane. The initiation step is going to be the photodissociation of the bromine, same as before, using H nu to actually make two new radicals, bromine radicals. We call this homolytic fission because they are both taking the same thing. They're both taking half of the bond, and you're left with these very reactive bromine radicals. Propagation steps then will be these bromine radicals reacting with the methane, and you're going to get hydrogen bromide, and you're going to get what we call a methyl radical, CH3 radical. Another propagation step could be one of those methyl radicals coming together with some bromine to make bromoethane, or methyl bromide as it's sometimes called, plus a bromine radical. The termination steps are two bromine radicals coming together to make bromine molecules, methyl radicals meeting with bromine radicals to make the methyl bromide, and two methyl radicals coming together to make ethane. Thanks for watching Guerrilla Chemistry. All the ads, please. That really helps to be more useful to more people. Also check out Guerrilla Physics and Guerrilla Biology for all your all your science needs.